Chapter 1, Introduction to Statistics, and Section 1.1. The best way to follow along with this video is to have your textbook out, to pause the video often, take notes, and try all the problems on your own by pausing and then pressing play when you're ready to compare the answers. The key concept in Section 1.1 is to understand the process involved in conducting a statistical study. So we're going to be looking at the prepare, analyze, and conclude. We're going to be looking at statistical thinking, making sense of results, and that it's a lot more than just calculating things in statistics. The vocabulary and important terms are as follows. And let's get started. So, data. Data is the collection of observations, such as measurements, genders, or survey responses, and we're going to go deeper into the types of data in Section 1.2. What is statistics, the class you're currently taking? Statistics is the science of planning, studies, and experiments. We're going to be obtaining data, organizing, summarizing, presenting, analyzing, and then interpreting based on the data, and then drawing conclusions. So we've got the language of population, census, and sample. So a population is the complete collection of all measurements or data that are being considered. We can't always access the population, but if we do want to access every member of the population, that survey would be a census, the collection of data from every member. But if we can't access every single member of the population, which is more likely, we take a sample, which is a sub-collection of members selected from a population. Let's take a look at an example. In this journal article, it was stated that there are 38 million carbon monoxide detectors installed in the U.S. When 30 of them were randomly selected and tested, it was found that 12 of them failed to provide an alarm. What is the population in the sample? So feel free to press pause, or if you want to see a fully completed example, stay with me. In this case, the population is all 38 million carbon monoxide detectors. Remember, the population is every member of the group that we're interested in. And a sample is the sub-collection. So the 30 carbon monoxide detectors that were selected and tested is our sample. Now it's your turn. Press pause, read the problem, solve it, press play when you're ready to see the answer. And here's the solution. The process for a statistical study involves preparing, analyzing, and concluding. Let's take a look at the prepare. When we're preparing a study, we want to look at the context. What does it represent? What is the goal? What is the source? Is there any sort of special interest or bias? And then how is the data collected? And the sampling method will go into more detail in future sections. So let's take a look at example 2. Looking at boats and manatee fatalities, and this is a personal photo of mine when I saw some manatees in 2019 in South Florida. So the table includes the number of registered boats in Florida and the number of manatee fatalities from encounters with boats for each of several recent years. And this data was collected from the Florida Department of Highway Safety and Motor Vehicles and the Florida Marine Research Institute. So what we're going to be asking ourselves is, what is the context, the source of the data, and the sampling method? If you want to pause it and try it on your own, feel free to do so, or I will continue on with this problem. So the context here is we're looking at registered boats in Florida and the number of manatees. It looks like the goal of this study is that we're trying to make it seem like there is a relationship, or to examine if there is a relationship between the number of boats and the number of manatee deaths from boats. Now, what's the source? The source is the Florida DMV and Florida Marine Research Institute. Both of these sources are reputable. So the sources are okay. There doesn't seem to be any sort of bias. Maybe if it was a boat company or some sort of anti-boat company, that might be some sort of bias, but these seem to be reputable sources. The sampling method, it's obtained from official government records, so we can assume that they're reliable. I understand if you're hesitant to say something like that, but it seems to be a sound sampling method. So what is a different kind of sampling method? And again, we'll be exploring that in later sections, but there's a voluntary response sample. It's also called self-selected sample, and it's one in which the respondents themselves decide whether to be included. This is flawed because we shouldn't really make conclusions about a population on the basis of samples with a strong possibility of bias. So here are some examples. An internet poll. People can decide whether or not they want to respond. Who are the people that are likely to respond? Mail-in polls. Who are the people likely to reply? Telephone call-in polls. Someone calls. Who are the people that are likely to answer? And who are the people that are likely to hang up? Are we going to get a true representation of the population in a sample where people can choose whether or not to answer? So let's look at an example here. Nightline asked viewers to call with their opinion about whether the UN headquarters should remain in the US. Viewers then decided themselves whether to call with their opinions, and 67% of the respondents said it should be moved. But in a separate independent study, 500 respondents were randomly selected and surveyed, and 38% of this group wanted the UN to move out of the US. So what went wrong? Which survey is better and why? Feel free to pause it or to stay with me. So the two polls are dramatically different for many reasons. You might say, well, first of all, we're only asking people in the Nightline viewers if they're already watching Nightline. So that's a specific population, a specific sample of the population in and of itself. And then it's a choice. Who are the people that are likely to call in? Maybe people that have some strong opinions or have extra time, and we're not getting a representation of the population. So that independent separate survey that are randomly selected and surveyed is a more reliable survey. Press pause, try these on your own, and press play when you're ready to see the answers. And there you go. Take a moment to review your solutions. So after we prepare, we look at analyzing. How are we graphing the data, exploring the data, and applying statistical measures? So using technology to obtain results. We're going to go into more detail with these later in the chapter and future chapters in the course. Concluding. So the final step in the statistical process involves conclusions, and we distinguish between statistical significance and practical significance. Statistical significance is achieved if the likelihood of an event occurring by chance is 5% or less. So getting 98 girls and 100 random births is statistically significant because it's such an extreme outcome that it's not likely to result from random chance. Whereas 52 girls and 100 births is not statistically significant because that could easily occur randomly. Now, first determining if something is has statistical significance, but then maybe it has that, but it doesn't have practical significance. It might not be worth the trouble, the money, or make enough of a difference to justify its use to be practical. Let's take a look at an example. Pro Care Industries once supplied a product named Gender Choice that supposedly increased the chance of a couple having a baby with the gender they desired. In the absence of any evidence of its effectiveness, the product was banned by the FDA. Suppose that the product was tested with 10,000 couples who wanted to have baby girls, and the results consist of 5,200 baby girls born in the 10,000 births. The likelihood of that happening just due to chance is only 0.003%, so chance doesn't seem like a feasible explanation. Does this have statistical significance and practical significance? Based on the definition of statistical significance, it does, because remember that statistical significance is anything less than 5% happening by chance, and so it does have statistical significance. But if you actually do the numbers, so let's take a peek here. 5,200 out of 10,000 gives us 52%. We'll talk about percents in a moment, so if you're not quite sure how I got that, that's okay. And 52% is really not that much more likely than just having a baby girl by chance. And so would you want to spend the money practically for just a 52% chance? And so we would say probably not, and therefore it does not have practical significance. Go ahead and give this one a try. And here's the solution.